Okay, here we're going to be investigating body joints. Body joints can be used for a high degree of flexibility, or it can be used to help in sports, kind of make different moves, and there's a lot of stress and strain put on joints in many sporting events. So joints in general, well, what are they? They're articulations of bone. The functions of joints, they hold bones together and they allow for mobility. And ways joints are classified both on their function and also how they are structured. So you can see here just a general joint here. We're going to learn more about the different types. Also our joints in the skull here. We may not consider these as being very mobile because they're not, but these nonetheless are still joints that occur in the body. The structural classification of joints, we have our fibrous joints, which are generally immovable. We get up here in our skull region, cartilaginous joints, which are immovable or only slightly movable. We might have those found, for example, the discs of cartilage that help support our vertebrae, and synovial joints. Those are the ones that are freely movable. And those are the ones we may think of initially when we think of a joint. Now, our fibrous joints are strong connections between bones. Bones are united by fibrous tissue, and the reason is they lack a lot of motion. Sutures are one example. They're non-moving joints of the skull. Syndesmosis are where ligaments connect two bones, allowing for minimal movement, such as between the ulna and the radius. And gomophis here is the specialized fibrous joint that anchors a tooth to its socket in the jaw. So all of these are examples of fibrous joints here. These fibrous joints are really strong connections and allow for potentially some movement, but not a lot or a high degree of movement. Very minimal in the amount that they can move. Cartilaginous joints are examples, are bones connected with hyaline cartilage. Symphysis here is compressible fibrocartilaginous pads connecting two bones, allowing for some movement. So of our minimal movement between bones, in this case we're having a padding that's occurring. That's why there's cartilage present there, and that's why it's considered a joint, but not a lot of movement between those. Synovial are immovable cartilaginous joints that can be found at the end of long bones. This allows bones to grow in length. And the pubic portions of the right and left hip bones of the pelvis are joined together by this fibrocartilage. And this area here, remember, if we want to identify a male or a female, we look typically in this region to be able to do so. Our synovial joints, as I said, probably the ones we may consider most as joints, and the articulating bones are separated by a joint cavity. Bone surfaces are protected by articular cartilage, and synovial joints are found in the joint cavity. There are 6 main different types all present here. What I like about this picture is not only does it show you all the joints, it also shows where you can find those on the body. I'm going to present these 3 at a time. So those synovial joints, the general structure of them, they have cartilage, they have that synovial cavity, they have the articular capsule, the synovial fluid, and reinforcing ligaments. These joints in which articulating bones are separated by fluid containing joint cavity. So the reason why we want this joint containing fluid is it helps create a nice lubricating barrier surface between the two bones. We don't want to have bone-on-bone contact. This fluid allows for ease of movement between these two articulating bones. So again, looking at some of the joints here, we have pivot joints, which provides rotation. At the top of the spine, the atlas and the axis, remember the yes, no, the C1, C2 vertebrae, they are actually portions of a pivot joint. The hinge joints move on just one axis, and these joints allow for flexion and extension. Major hinge joints include the elbow, and also our finger joints. So these are examples of hinge joints. Saddle joints are for flexion and extension and other movements, but no rotation. In the hand, the thumb saddle joint between the first metacarpal and the trapezium lets the thumb cross over the palm, making it opposable. So our opposable thumb would be an example there, and that's called a saddle joint. Plane joints move against each other in a single plane, and we see that indicated here. An example on the body would be between the tarsal bones. Also, major gliding joints include the invertible joints of the bones of the wrist and the ankles. So remember, our ankles share a lot of similarities with our wrists. The condyloid joints allow for circular motion, flexon, and extension. These are wrist joints between the radius and the carpal bones. So in this specific region right here, we have that example of that circular motion that occurs. And the ball and socket joint is a freely movable joint that can rotate on any axis. An example of that here would be our hip joint, the top portion of our femur articulating with our hip bone. Now, talk about joints, talk about cracking our knuckles. So what causes our knuckles to pop? You can go through and watch some of these videos and help understand a little bit about what's actually going on with when we crack our knuckles.